Hello good people and welcome back. So in the last video what we did is we went over a couple of items that we need to pay attention to as we set on to estimate the futures price on interest paying securities. In this case interest rate futures, for example. In this case we played with bond, a treasury bond. Now what I want to do before we jump into what comes next and talk about other kind of interest rate futures, to wrap up the discussion that we had on bonds, I want to do an example that gets everything, that puts everything in context. And the example that we're going to work in is essentially the same that you have in your book, and I'm going to walk you through that example, and that is the following. That is example 6.2 that is in your textbook. Okay, so look at 6.2 in your textbook. What I do though is that what I do have is that I do have a different conversion rate here, and I have a different quoted price there. So that's what essentially those are the key differences that we have, and I'm going to be working through this slowly. And that summarizes essentially all that we have. Now, here is the scenario that we're working with. We have two parties. We have a long and we have a short. Now, the long enters in the forward contract or futures contract to purchase the bond, which is in this case we're working with the treasury bond, at some point in the future. And now that point in the future happens to be delivery date, and delivery date is going to be 270 days away. Now the bond itself that we're looking at is a T treasury bond with a 12% coupon, semi-annual compounding. The bond here paid the last interest. The most recent interest paid was 60 days ago. The next interest payments are going to happen in 122 days and in 305 days. The realized the interest rate, which is continuously compounded, is going to be 10%, and it's going to be a flat curve. The flat curve there simply means that we're going to have, for different maturities, we're going to have the same discount rate, the same interest rate of 10% there. Now you compare that to what we worked with in a couple of units ago when we created the zero curve. Here we're having the same rate for different maturities, whereas when we're having a zero curve, we have a different rate for different maturities. So our goal is to find exactly what is this quoted price. This quoted futures price should be. Now, a quoted futures price is the price that you'll be paying for the bond, right? At that point in the future. So, in theory, our quoted futures price should be equal to, let's call that so the quoted futures price would be essentially, we would have a dirty, let me put it this way, a dirty futures price, which is going to be equal to the clean futures price plus accrued interest. That's the idea. The dirty futures price is going to be equal to the clean futures price plus accrued interest. Now, the clean futures price is what is the quoted price. And we saw in a video earlier, in the earlier video, that this clean futures price is the clean futures price for the cheapest to deliver bond, right? And that cheapest to deliver bond, because we have a range of securities that can be delivered over that period, that cheapest to deliver bond is going to be computed, or that price is going to be computed as a function of the conversion ratio. So really what we have is a cheapest to deliver bond that is, for this clean price, that is a function of our quoted price. So this is going to be our quoted futures price multiplied by the conversion ratio. So essentially what we have is we're going to have a dirty future price, which is going to be equal to the quoted price multiplied by the conversion ratio. That's what makes up our clean price or clean futures price. And to this, we're going to add accrued interest. And our goal ultimately is to find what is this quoted futures price. That is what we're after on that specific bond that's to be delivered. So to do that, let's work slowly. Remember, our futures price, our dirty futures price, essentially is expressed as the total, right? It includes accrued interest, and that is what our expression, our formula gives us in general. So our formula F0 is equal to the spot price minus any income that we have, minus any income that we receive, and then we take the future value of that over a period of time. This value that we have here is essentially our dirty futures price. So we're going to find our dirty futures price. We're going to use our dirty futures price to find our quoted futures price. And to find our quoted futures price, we're going to be doing the following. We're going to find our dirty futures price, and I'm going to just say our quoted futures price here is going to be equal to our dirty futures price, which is that value, minus accrued interest, right? Because we are solving for this value here. So we're going to take this minus the accrued interest, and then we're going to divide our answer by the conversion factor. And that's how we obtain our quoted futures price. Now, our dirty price, remember, is going to be this following. So we're going to have quoted price is going to be equal to our dirty price, which is S0 minus our income future value, from which we subtract the accrued interest, and we divide all of that by our conversion factor. So what do we need? We need S0, we need I, we need our interest rate, we need T, we need our accrued interest, and we need our accrued interest. We have our conversion factor. So let's see what we have. S0, which is today's price of the bond, we don't know yet. So actually we do. It's given to us. It's the quoted price. That is the 120. So that's given to us, and that's 120. Our income is going to be the present value of the dividend, that's the interest that's received over that period, over the life of the futures contract. We don't have that value yet. We need to find it. And so we're going to put a question mark here. We're going to need to find it. We do have interest rate, so R, we do have it. Remember, we said it's continuously compounded, and it is also a flat curve. So R is going to be at 10%. The maturity of our contract, which is T, we are told that the contract is going to be delivered in 270 days. So it's going to be 270 days, but we're going to express that in years, right? So it's going to be 270 days divided by 365. There are 365 days in a year. All right. So we do have what we need. The only thing so far that we do not have is the income. And we remember that the income is going to be the present value of the coupon payment that is received during that period. Next, what we need to find is accrued interest. And before we get to accrued interest, let's check the conversion. So our conversion factor is going to be equal to, our conversion factor is going to be equal to 1.4, and that is the value, that is the value that we have, that we're given here. So we're given the conversion factor as well. We don't need to find it. Finally, we need accrued interest, and we don't have the accrued interest. However, we know that the accrued interest is computed as the our accrued interest is essentially going to be computed as x divided by y multiplied by our coupon payment for the period. And that's what we know. Now, we also need to remember that this so far is simply a spot price. Well, we do need though to find the price of the bond at this point in time, right? So our spot price really doesn't include any accrued interest, right? Because what we really want to do, what we really want to find, actually I need to correct this, what we really need to find is this value plus any accrued interest if that exists. If that doesn't exist, then we don't need to worry about that. So S0 there is going to be equal to just like a dirty price. So we're going to have a dirty S0, which is going to be equal to the clean S0 plus accrued interest. And so to find our dirty S0, our dirty spot price, we need to use the clean spot price, which is the 120, which is the 120 here, to which we're going to add any accrued interest if those exist. And that's essentially the goal. So here we need to verify that there is no accrued interest, and we also need to verify what accrued interest it is that we're using. This accrued interest we're using down here is the interest that's accrued within this period, within this 270 days, right? The accrued interest that we use here is the accrued interest that's earned before we get into the contract. So let's draw a timeline. Our timeline is going to look something like this. Alright, so we're going to be here at some point here, and this would be for us what today is. So this is going to be today. The last coupon payment that was made on this bond happened here, so that was 60 days ago. So if 60 days ago was 0, today is going to be 60. So 60 days ago, a coupon payment was made. So we can say here that was last payment. We are also told that the next payment, and that's what we're told up all the way up here, the next payment are going to occur in 122 days and 305 days. So we're going to do the following. In 122 days, let's say that is here, day 122, we are going to have the next payment. And on day 305, we are also going to have another interest payment. So we're going to have two payments after today, and we had one payment before. Now, what we need to do here is to find where is our delivery date. Now, our delivery date is going to be in 270 days, right? That's what we're told here, 270 days. So we go all the way here and we say, well, 270 days is going to place us somewhere around here. So that's going to be 270 days, right? So we're today, we're going to have 270 days from today. We had 60 days from this date. Next, what we need to do is we need to figure out what is, at this point, what is the dirty S0 spot price. Now that dirty spot price is going to be equal to the clean spot price plus any accrued interest. Now remember the last interest payment was made here. The next one is going to be made here, which means that there is an accrued interest there is interest that has accrued over this 60-day period. And so our dirty spot price, just going to keep calling that dirty spot price. So our dirty S0 is going to be equal to our clean S0, which is 120, plus the accrued interest. Now, how is it that we compute accrued interest on this type of bonds? This is a treasury bond, right? And the accrued interest on treasury bond is computed using actual to actual. On corporate bond is computed using 30 to 360, and on the funds it is computed using actual to 360. And those are the options that we're going to have. So for now, our money market instrument is the actual to 360. So for now, what we need to do is we need to figure out what is X, what is Y for this dirty spot price. So X is going to be this distance here, that is the number of days within this period, and Y is going to be the number of days between payment, and the number of days between payment is this distance between these two payments, so that's going to be Y. Now, how much interest is going to be paid? I deleted that. There we go. How much interest is going to be paid over this period? Well, the amount of interest that's going to be paid over this period is going to be coupon rate. And so our coupon rate is going to be equal to, our coupon payment is going to be equal to the flat price, the face value, multiplied by the coupon rate, which is 12%, divided by 2 because it's semi-annual. So that's going to be 12 divided by 2, so that's going to be 6. So our coupon payment is actually going to be equal to 6. Alright, so what does that mean for our accrued interest? Accrued interest is, remember, it is X divided by Y multiplied by our coupon payment. So what is X in this case? Well, X is going to be 60 days, so that's going to be 6, our coupon payment, multiplied by 60. I'm going to clean this up. There we go. Multiply by 60, and we're going to divide that by, what's the difference? What is Y? Y is going to be the period from the last payment to the next payment. Okay, what is that? The next payment is going to be 122 days from today. So this is going to be 122 days, and the last payment was 60 days ago. So we're going to do 60 plus 122. And that gives us our dirty spot price. Or that is the price of the bond that a long party or the short party of this deal would have to pay, right? That is what the price of the bond is. If somebody were to purchase the bond today, that's how much that person will pay for the bond today. And so that would be equal to, let's pull our financial calculator, and we do just that. So it's going to be 60 plus 122 equal 182. We do 1 over X multiplied by 60 equal multiplied by 6 equal. So that's going to be 1.97. And to that, what we're going to do, we're going to add 120. So plus 120. And what we're going to have is 121.97. So our dirty price is going to be 121.97. That's going to be our dirty spot price. And so for our purpose, that is S0. So S0 is found, and so we can go back up here and say we know what S0 is, and S0 is going to be equal to 121.97. That is S0. Now, what is our income here? Now the income is going to be the present value of a coupon that is earned over the life of the futures contract. Now what is the life of the futures contract? The futures contract starts today and expires in 270 days. So this is the life of our futures contract here. We also see that we have a payment that's going to be earned in here, right? A payment is going to be earned here. And so the accrued interest, the contract is going to settle down here. The accrued interest over that period is going to be essentially over this last period here. So the period since the last payment until the next payment, and we're looking at the period between, right? So that's what we're going to be looking at. That interest, and we're going to find the present value of that coupon. What is that? What is that coupon payment? There, the coupon payment that we are receiving there here is going to be equal to the $6. That's the same thing. So I, which is our income, is going to be equal to the $6 that we're going to be receiving. But then we need to find the present value of that $6 today, right? The present value of the $6 is going to be equal to the following. Present value, which means we raise that to the power of e to the power of, our interest rate is 10%, because present value we do minus 10%. And the time period between today and the next payment is 122 days. Now, the 122 days is expressed in years, so it's going to be 122 days divided by 365. That's going to give us the present value of our income. Our income is $6 because that's what we're going to receive on the next payment. We need to find the present value of $6 from 122 days to today. And that 122 days expressed in years is 122 divided by 365. Our interest is 10% flat curve, so we're using 10% there. And ultimately, what do we have? We have the following. I'll pull my financial calculator and do just that. We're going to use 122 divided by 365. That's equal to 0.3342. We're going to multiply that by 10%, so 0.1 equal. That gives us that value there. We're going to put the negative sign, that's minus. We're going to do the exponential of that, so second function exponential. And we're going to multiply that value by 6, so times 6 equal. So we have 5.802. That would be our, or 5.803, to round that up, that would be our income. So our income here, I, is going to be equal to $5.803. And that is our income. We can check that box as well. So what is missing? So far, we almost have everything that we need. What we really, we have our spot price, our dirty spot price. We have our income. We know what our interest rate is going to be, is 10%. We know what T is going to be, is 270 days. That's what we have. And so we need to find the accrued interest at that point in time. At this point in time, if we were to sell the bond at this point in time, what would be the accrued interest given this I'm going to use a different color here. If we were to sell the bond at this point in time, what would be the accrued interest given this payment that is made here? So the accrued interest would be for this period. Now, that accrued interest would essentially be equal to the following. Well, remember, it's still $6 that's being paid. So our accrued interest, AI, is going to be equal to the $6 that's being paid multiplied by the number of days since the last payment. And the number of days since the last payment, in this case, the last payment is going to be this date here. That was our last payment. And so the number of days since the last payment, which is X here, is going to be equal to the 270 days minus 122 days. That gives us this length of time here. And we're going to divide that by the number of days between payment. That is between 175 to 122 days from today and 305 days. That is the date between two payments. So it's going to be 305 minus 122. All right, so let's do just that. We're going to do 305 minus 122 equal, that's 183. We take the inverse of that. We're going to multiply that by, we open parenthesis, we do 270 minus 122, close parenthesis, that's 148 equal, and then we multiply that by 6. So the accrued interest over that period is going to be for $4.85. So this is going to be $4.85. What was that? $4.85.2 cents. So that would be our accrued interest. All right, finally, we have everything. Remember, what is our quoted our quoted futures price? Our quoted futures price would be our dirty futures price, which is this value, minus any accrued interest that's earned over this last period of time we have there, divided by the conversion ratio, and we have the conversion factor or conversion ratio. So let's do just that. Our quoted price is going to be equal to S0 minus the income, future value of that, minus our accrued interest, divided by our conversion. So let's plug in the values. That's going to be equal to, our dirty S0 is 121.97 minus our income is 5.083803. Future value of that is exponential of 10%, so that's going to be 0.10 multiplied by t here, and t in this case is going to be the distance between the periods. That's going to be expiration and today, and the expiration and today is going to be 270 divided by 365, and from here we're going to subtract our accrued interest, which is 4.852, and divide all of that by our conversion ratio, and our conversion ratio is going to be 1.4. All right, so let's do just that. I'm going to pull my financial calculator. I'm going to clear that. So I'm going to start with what we have in exponential. So I'm going to do 270 divided by 365. That gives me t. I multiply that by the interest rate, which is 0.1, equal. That gives me the value that I need in the exponential there. I take the exponential of that. That gives me 1.0767. And then I multiply that value by, open parenthesis, the difference between 121.97 and 5.803, close parenthesis, equal. So that is 125.08, and then I subtract the accrued interest, so minus my accrued interest, which is 4.852, equal. That gives me 120.233, and I divide that by my conversion ratio, so divided by my conversion ratio of 1.4, and I'm going to have 85.88. So ultimately my quoted forward price or futures price is going to be 85.88 dollars. Now you remember that this is the quoted futures price, right? And so as the quoted futures price, which is, in a sense, we remember what we said, the quoted futures price is also very similar to what we called our clean futures price, right? So we have the quoted and we multiply by conversion, we add accrued interest, we have the dirty. So let's do just that. Let's verify this. So we have our quoted. How much does the short party actually receive? We need to adjust that by the conversion factor. That is going to give us the value for the cheapest to deliver bond, and then we're going to add accrued interest. And so if we did that, we would essentially be doing the F0, which is exactly what the short party is going to be receiving, is going to be equal to the 85.88 that we have quoted, multiplied by the conversion factor, which is in this case 1.4, and then once we have that value, we need to add any accrued interest, and our accrued interest is going to be 4.852. So that's going to be the settlement price, conversion, accrued interest. Let's go back to our slide and see exactly what we had there. On our slide, I think it was over here, we said that the cash price received by the short party in the position is going to be the most recent settlement price, and that is the essentially the clean price that we refer to. That's the most recent settlement price there, multiplied by our conversion factor. Our conversion factor was 1.4, and our accrued interest was computed there. Overall, what we obtained is the actual amount of money that the short party is going to be receiving. However, the quoted price on the futures is going to be that value here, and our quoted price on the future here is going to be the 88.88. Now, I hope this clarifies the discussion that we had in the earlier video. What we're going to do next is I'm going to stop here for this video because this is just an example, and it took about 30 minutes to work this example as a whole. But what we're going to do next is talk about different type, and this was for the treasury bond, right? Remember our example here was on the treasury bond, and we remember that we use actual to actual for T-bill. Now we're going to look at another type of interest rate futures, that is euro dollars, in the next video. I'll see you in the next video.